Many people all over the world use a machine, be it manual or automatic, to make their coffee every single morning. But have you ever heard of using coffee to power a machine? Let's go and make a cup of coffee and see what I'm talking about.
So now that we have our cup of coffee in a mug that would keep the heat while we get set up, we're going to demonstrate how it can power this machine here. So as you can see now, it doesn't really do much. Stops almost immediately. But watch what happens when we set it over the cup of coffee. So now that it's over the cup of coffee, we gave it a chance to heat up the bottom part of the machine. Let's see what it does. So you can see here that the coffee keeps the machine turning. Now, while you might think this is due to the heat, it's actually due to the change in temperature of between the two plates. The bottom plate is much hotter than the top plate, and this difference in temperature drives the pistons. This machine is actually a great example of entropy. Because of the difference in temperature between the two plates, the piston tries to equilibrate the temperature between the two in order to maximize entropy. When this bottom plate heats up because of the coffee, it drives an expansion inside of the chamber here, which in turn moves the piston and moves the flywheel. In doing so, it works to equilibrate the temperature between the two plates, thus driving the machine with coffee. However, due to the difference in temperature being the reason that this machine runs, you can also run it on ice, as we'll demonstrate now. So now that we've given the machine a chance to cool down some, let's see if it works on ice. And not to my surprise, it does. Because again, it works on the change in temperature between the two plates and not actually the heat. It's interesting to see a machine that doesn't run on something like the burning of fuels, but the maximization of entropy. And that makes the Stirling engine here, with its expansions and compressions due to changes in temperature and maximization of entropy, a working definition of entropy and how it always tries to maximize freedom. Eventually, when this ice melts or the top plate gets to the same temperature, once it reaches equilibrium due to the machine running, the machine will stop and entropy will be maximized as it is at equilibrium. Interestingly still, if you were to spin the flywheel enough, as you can see there, it stopped it. You would be able to create the difference in temperature between the two plates just by spinning the wheel. And then you might say, well, this energy is coming from nowhere. But at the same time, you're using a lot of energy from your hand, your arm, to spin the flywheel, and you're also letting off heat into the universe that way, so no energy is truly free. So now let's talk a little about how this Stirling engine is working. Here we have a thermodynamic diagram of what exactly is going on. So in this case, it has the hot section going first with the heat in, turns the Stirling engine, creating the useful work and the heat out into the universe. So this is an example of where all of the energy is going while it tries to reach equilibrium. So here we have an example of what is going on to the fluid inside of the Stirling machine. This shows the volume on the x-axis and the pressure on the y-axis. This diagram shows the expansions and compressions that is going on inside of the Stirling machine due to changes in temperature from 4 to 1 and 2 to 3. While at 3 to 4 and 2 to 1, you see the temperature remaining constant as the conditions change due to the fluid expansion and compression inside of the chamber. And this is largely in part what drives the Stirling machine, in addition to the arms and pistons that are connected to the pistons. While we don't know the actual compression ratio of this specific Stirling machine, if we did, we could use this equation along with the temperatures of the two plates in order to calculate the work being done by the Stirling machine. This would be handy in an application with a product that you were designing using a Stirling machine. And so there you have it, a machine ran by coffee. Just like many people all over the world are ran by coffee when they make their trip to Starbucks or Dunkin' Donuts, or use a machine to make their coffee every morning. So now when somebody asks you, have you ever heard of a machine ran by coffee? You know what to tell them.